today we have already started with the photoelectric effect. In the last class I had already explained you what is photoelectric effect. Today we will be doing with the laws of photoelectric effect, and we will be determining the value of Planck's constant with the help of the graph. So first let us see what is the law all about. I have already explained in the last class what is the photoelectric effect. It is just a phenomena in which the electrons are ejected out of the metal surface when the light rays are incident on it. And the light which is incident on the surface carries the energy h nu. And we have derived the Einstein's equation also. And this energy is utilized in two ways. First, it imparts certain energy to the electron so that it comes out of the metal surface, that is given in terms of the work function. And secondly, it gives also kinetic energy to the photoelectrons so that they can move out, and then there is a potential difference created, and as a result you are getting the current. Okay, now the first law says that for a given photoelectric surface, for a given photoelectric surface, photoelectric current I suffix p is directly proportional to the intensity of the light, incident light, and is independent of a frequency. Okay, so if you are plotting a graph between this is the photoelectric current and this is the intensity, you get a straight line. This is the intensity and this is the photoelectric current. And suppose if you are plotting a graph between the frequency, this is the frequency and this is the photoelectric current IP, you get graph like this. It is independent, and this is what is the nu naught is what? Threshold frequency. I had already told you threshold frequency is the minimum value of the frequency after which the emission of electrons takes place. So this is called the cutoff frequency also, or the threshold frequency. So it is not depending. The frequency, the photoelectric current does not depend upon the frequency. That is the first law. Okay. The second law, according to the kinetic energy of photoelectrons. Kinetic energy of photoelectrons is directly proportional to the frequency and is independent of intensity incident light. Independent of intensity of incident light. So what does it shows? That the kinetic energy of the photoelectron increases as the frequency increases, but then again it is not depending upon the intensity. So there are two different things. Here we are talking about the photoelectric current, and here we are talking about the kinetic energy of the photoelectrons. So these are the two things that you need to know. And other than this, the properties, if you say get the properties of photoelectric effect, the process is instantaneous. What does it mean? The moment the photon falls on the surface, the electron is immediate, is just ejected out, and that is without any delay. There is no lag. Okay, that is why it is called instantaneous. Second, then it is one-to-one effect. It means that a photon always, if there is a photon, it will always cause emission of an electron. And we very well know that the work function is low, then the ejection of the electron becomes more and more. Now next we are going to find out the value, that is the determination of Planck's constant, determination of Planck's constant with the help of graph. From the graph. Okay, so let us draw the graph first. This is a graph. This is a stopping potential. This side we have taken stopping potential. And here we have taken the frequency nu. So this is what we are getting. This is the negative intercept and this is the slope of the graph. Now this part is, this is V, okay. So this part will represent delta V and this is nu, so this part will represent delta nu. This is representing delta nu, okay. So if we have to write down the slope is equals to delta V by delta nu from the graph. This is the graph. This is the nature of the we are plotting a graph between the stopping potential and the frequency. Now let us take the Einstein equation first. What was the Einstein equation? We had the condition h nu is equals to h nu naught plus we had taken EV. That is the amount of energy is used, this is the work function, and it is the kinetic energy. We had taken the kinetic energy EK as equals to small e capital V. Capital V is the stopping potential. And I had already explained what is stopping potential. It is that negative value of the potential. It is the negative value of the minimum negative value of the potential which is there for the plate, for which the photoelectric current becomes 0. Okay, so this is that particular value of potential. Now h nu naught is giving us what? H nu naught is giving us work function. Okay, so let us write this equation. EV equals to h nu minus h nu naught. I can write EV. So this is h nu minus h nu naught, and we can very well write V as h by E nu minus h nu naught by E. Now this is V. This is V. If I compare with the comparing it with straight line equation. Y is equals to mx plus c. If you compare this with this, you will find that we can very well write this equation. This is what we have got, the independent variable new frequency, and dependent variable is the V, that is the stopping potential. Okay, so here if we compare it, this is the intercept, this whole value is the intercept. If you get to see the graph, this whole value is given by the term h nu naught by E. This value is given by h nu naught by E. This is the threshold frequency value. Okay, so if you compare this, you get slope m as equals to slope, and this is equals to h by E. So h is equals to E into slope of the graph. And if you get to see, E is the charge of electron. And here we have got the slope of the graph. We had already got delta V by delta nu. That is what we have got. We can substitute and we can get the result. I hope you must have understood this very nicely. How from the graph we can calculate the value of the Planck's constant, and this is pretty easy, because if you're comparing it with the straight line equation, you find this as the intercepts. See, This is what we have got, the intercept h nu naught by E value. So suppose if you have got a reading and you have been asked to find out the cutoff frequency, you can get the cutoff frequency from here and get the work function from here. So this is what you are going to get it. Okay, so this is how you can do. Thank you for watching.